Okay, guys, I think we can start today's session. And Today's session will be a short session. What I'm planning is to discuss an important part of ROS 2, which is fundamentally the architecture. So, I am actually in this chapter migrating from ROS 1 and ROS 2. So, basically, when we start discussing with ROS 2, it will be better if we compare the main changes. Okay, there are many changes, but we are just talking about the main differences. Okay, and also we can see the architecture, the general architecture diagram of ROS 2, and then after seeing that we can start discussing about the basic concept. Like I already mentioned that the ROS 2 concepts are same as ROS 1. I mean, almost same as ROS 1. So we will be repeating this thing like that we have seen in ROS 1. We will be starting with ROS 2. I mean, this chapter is actually the same. I mean, if we discuss this concept, it is the same thing that we are discussing here. Okay, the architecture concept, then file system, all these things are same. Okay, so what I'm planning is combining this migrating from ROS 1 and ROS 2 and kickstarting robot programming using ROS 2. We can do it in a single stretch. I mean, there is not much difference. After discussing the main differences, we will be jumping into installation. Then we will be seeing the basic concept in ROS 2, then ROS 2 programming, then simulation, all this stuff. Okay. Okay. So I just want to share a document in Discord. Okay. Let me share that. One second. That is the um, that is a main paper, the base paper of ROS 2. I think I also shared the base paper of ROS 1 when we started working on ROS 1. So I hope you got um, the paper. You can just check that, and that is what we are taking as a reference today. Okay. So can you please open it, guys? In my PC, it's already open. One second. Yes. So this is the paper that I'm talking about. One second. Okay. So the title is Robot Operating System, then Design Architecture and Use in the Wild. So basically, if you simply search in web ROS 2 architecture or something, you will get multiple links, and one of the key website is ROS 2 Design. This is somewhat old, okay, but it is having the stuff. Okay, I'm sharing this website. One second. Okay, so this is having core technical content of ROS 2, the design and everything. So if you check why ROS 2, there are a lot of explanation. But I don't know, like if you read by yourself, you can able to digest all this stuff. Okay, maybe you have to read twice. So what I'm trying to do in this session is like a kind of a discussion, um, the things that they mention in the paper. Okay, so in the paper they mention the same stuff, not all the stuff, because in the website, in the ROS 2 design website, they mention in deep. Okay, so this is the paper that I'm talking about. Okay, robot operating system, design architecture and use in the wild. Okay, this is the paper that we are using now. And so let's take the paper. You can see the authors of this paper. Steve Mackenzie, he is the author of the navigation stack 2, okay, in ROS 2. We will be discussing that later. And Tully Fute, he is the manager in Open Robotics. Currently, I'm not sure you heard about the acquisition, the intrinsic acquired Open Robotics. Okay, but the roles will be maintaining by Open Robotics. There will be a separate entity like an um, uh, kind of non-profitable organization, but that team will be also working with Intrinsic. Okay. Yeah. And Brian Gerke, he's the CEO of Open Robotics. Currently, I think he's the main employee in Intrinsic. So these are the authors, and I just want to, I mean, um, I just want to say like if you can just go through it, it will be better. I can just give an abstract of the paper. I didn't read it completely. Maybe I can give abstract up to the content that I have read. So first, they are actually talking about different software frameworks. Okay, specifically middlewares that is available, and the relevance of ROS 1 and ROS 2. Okay, the thing is that you maybe heard about DARPA self-driving challenge, right? You maybe heard about this. This event was one of the main event that triggered the self-driving car revolution. Okay, so you may be thinking like, what kind of software these people are using, because it's actually happened in 2006-7 at that time. So how they program this robot? Okay, it's a valid question, right? So at that time also there were framework similar to ROS. Okay, it's not like ROS, but there is a middleware. Okay, you know the main part of ROS, right? It's a communication middleware. So these guys use some kind of communication. So they created multiple programs that we are doing in the ROS one. ROS, we are writing ROS nodes, and it can able to communicate, right? So similarly, these guys create separate program, because these robots are pretty complex. Okay, there are like 9 lidars. Okay, and you have to handle it separately. You have to take these lidar, then IMU, GPS, all this stuff. So it can be programmed only through inter-process communication. Okay, there are multiple I mean nodes running, and these nodes should be communicating. Okay, so at that time they have been using different middlewares. So they in this paper they are mentioning about some communication technology like ZeroMQ, RabbitMQ, then YAP. So they are mentioning that actually MQTT. It's not that old, but you can find YARP is another middleware, and one of the middleware I mentioned about was LCM middleware, which is maintaining by MIT, I guess. So it stands for lightweight. What was that? It was there here. Yeah, it's for like very lightweight application or something. Okay, I can share the links, by the way. You can have a check. So there are some existing middleware in order to work with robots. I mean, before ROS. Okay, before ROS itself, there was middlewares like this. Okay, but the problem is that there are not enough support. Okay, there are not enough support, and there are not properly maintained. That is also one thing. So the community is a big problem. Okay, so after ROS was mainly like developed in Willow Garage. I think in the paper they are mentioning that clearly. One second. Yeah, and even these framework exist, ROS actually different. It's actually different compared to this, because it's not only a middleware. Okay, it's not the main part, obviously the middleware, but it is having a lot of other stuff. For example, the main reason why people are switching to ROS is obviously the capabilities. I hope you heard about the different capabilities, the navigation, manipulation, and the list goes on, right? So ROS is not only just a middleware, it is combined with a lot of algorithms that we can use, readily without, without doing any programming, okay? But all other frameworks, like if you check all other middlewares, it's not like that. Okay, it's not like ROS. So ROS is having definitely an edge compared to other middlewares. Okay, and one of the factors why ROS become popular is the name itself. The name robot operating system, it's actually unique, right? So it's very catchy as well. So it started in 2007. That time Willow Garage developed this framework, okay, ROS 1, and their intention was not like using in the product. It's basically research. Okay, so one second. Yeah, it's basically research. But what happened was the ROS really, they got a lot of people, a lot of developers, open source developers, and it went viral, I will say. Okay, during that, I remember 2007 to 2013. I came to know about ROS in 2010. So a lot of people are started using it because there was no framework, no such kind of framework exist that time. So you can easily find the main capability and also the weak point. Okay, so what they are saying is RO is designed for research, but people started using in products by doing some workaround. The main problem with ROS 1 is the security is one thing, and also it's not product ready. Okay, and also like they're mentioning like it's not suitable for low bandwidth communication medium. Okay, so there are some weak points. Obviously there are some weak point in ROS 1. The main weak point is, like I mentioned, it can't be used in product. So that is, if it is only a research product, then it will be failure all the time, because the acceptance of a framework, if it is used in a product, then only it will be commercially successful, right? So that's how the ROS 2 comes. Okay, so this is the main difference they are pointing out. So the main points, like if you compare ROS 1 communication protocol, or like how the nodes are communicating, they created a protocol. In ROS 1 they created a protocol called TCP ROS. Okay, that is a custom protocol they have created, and basically the underlying protocols are TCP and UDP. But there is a main change happen in ROS 2. Okay, so why this communication protocol change? Because there are a lot of issues with the latency and all. Like if you are working with ROS 1 in over a Wi-Fi, okay, like in if you are working with ROS, you can work with multiple computers by setting a ROS network address and all. So in that case, ROS 1 will not give the reliable output. It can give, but there are a lot of problems that we will face. Especially, I can say an example, like when I work with drones and all. We have been using Wi-Fi, and drones will fly, and there is a station, I mean remote computer. So the drone always communicating to the Wi-Fi, and the computer also communicating to the drone. And what happening is that there will be issues like when we receive the data and all, because if there is any latency comes, then we will not get the satisfiable output from the sensors and all. Okay, so there were issues in ROS 1. So that is the main thing in ROS 2 that is fixed. So there is a thing called DDS, Data Distribution Service. So if you just go to Google and search about DDS, you will get the exact concept. I mean, it will be difficult when you read and understand. Obviously, we don't need to understand the core aspect of DDS, but just the abstract idea what is DDS using for. And the abstract idea is DDS is it's a communication middleware. Okay, what that means is that if you have a DDS library, okay, DDS stands for Data Distribution Service, and that is kind of a standard. Okay, we heard about the ISO standard, or like there are software standards or something like that, right? So DDS is again a standard, and using these standards, anyone can build DDS based libraries or DDS based frameworks. Okay, so there are some good DDS standard libraries available, and some of the libraries are like paid and some of them are free. So using these DDS, you can able to communicate between different programs. Okay, even if you don't need to use ROS or ROS 2, if you only have DDS library, you can write nodes. Okay, so that is what it's showing here. I can show that 1 second. So it's like the DDS library will be providing C++, C, Python APIs, mostly C and C++, I guess. So you can write a program using the DDS API, and then it will be communicating with the other nodes. Okay, so in ROS 2, what happened was, instead of the custom TCP ROS protocol, they actually change into DDS. So it's like a heart transplantation. Okay, and for your information, ROS 1, it's not like an update of ROS. I mean, ROS 2, it's not an update of ROS 1. Update means like improving the features of ROS 1. Okay, from 2007, ROS 1 is there. I think after working for like 5-6 years, the open robotics, they got an understanding of the limitations and the limitations of the framework, obviously, and also what people really want. Okay, what they are expecting. So they got the expectations. So then they started working to create a entirely new framework, which is like not compatible, I will say, but it is similar to the ROS 1. Okay, so they changed everything, they written everything from scratch, and in 2016 or something, ROS 2 development happened by Open Robotics. Okay, so the first thing they have done was heart transplantation. They simply took the heart, they changed everything, and that is a major change. Okay, and what happened if you do this modification? If you do this modification, meaning if you change the TCP ROS that we are using in ROS 1 to DDS library, then the thing is, the TCP ROS was like it actually need a main central server called ROS core. Okay, we had the ROS core working in ROS 1, right? Like we have to run the ROS core first, and then we have to run the ROS nodes, right? But imagine the ROS core crashed. Okay, ROS core crash. Then the entire system is just freeze. So that is a single point of failure, right? Whenever the ROS core crash, the communication will go crazy. Okay, so that is very important point. Like the single point of failure is there in ROS 1, but in ROS 2, because of DDS, we don't need to worry about ROS core. There is no ROS core at all. Okay, so the main change is that you don't need to enter ROS core. You just need to run the nodes. Okay, so that is actually a great upgrade, because otherwise we always need to worry about whether the ROS core is running, or is it closed properly, or a lot of things to consider. But in ROS 2, only consideration is to the nodes. So if you run a node, and if it is publishing a topic, and if you are running another node which is subscribing that topic, that's it. It will work. Okay, so this peer-to-peer discovery will be doing by DDS. Okay, so you can understand the main part is DDS, and ROS 2 is actually a framework built around this DDS. Okay, and I will say the main flexibility that ROS 2 provide is that we can change the heart. We can change, or like if you don't want a DDS library, you can switch it. Okay, that is a great flexibility, because I mentioned that DDS is a standard. Okay, and there are many libraries. So if you compare many libraries, for example, if you check, let me check DDS middleware list. If you just check, there are many libraries available. Okay, there are many vendors who are creating these DDS libraries. Okay, 1 second. They're not mentioning. Yeah, there are like Cyclone DDS, Fast RTPS. There are a list of middlewares available using the same standard. Okay, so each middleware having their own, its own advantages. Okay, maybe some middlewares are good for real-time application. Okay, some will be good for general use cases. Okay, so if you want to specifically do an application using a specific middleware, that is possible in ROS 2, which is a good thing. So you can customize your heart. Okay, it's like customizing our heart. You can simply transplant it. Okay, so that is what these two stuff. Okay, we can change the DDS. There is no use of ROS core, and in ROS 2 we can simply run the nodes. Nothing to worry. Another great add-on is this. I mentioned that it will be better to work with Linux in ROS 1, but the ROS 1 can be also run in Windows. Like Microsoft actually ported a lot of packages in ROS 1, but it will work, but we can't say it is stable. There are a lot of bugs. Okay, but in ROS 2, what they are doing is they're trying to make ROS as a multi cross platform. Like you can write a node which will be working on uh, Linux, Windows, OS X. Okay, so that is another great add-on. It will be working in Windows and Mac OS, but I will not recommend Windows for now. Okay, um, and Mac OS, because I still believe that Linux is having a lot of potential while working with robots. Okay, because of the customizability. Okay, so that's why I'm sticking on to Linux, but that doesn't means that we can't run ROS 2 in Windows. We can. Okay, we can run, but Linux giving more flexibility. For example, if you are working on a Raspberry Pi, okay, as a main module in your robot, if you are working with Linux, you can customize the OS. Okay, you can remove I mean, you have complete access to the operating system, and you can run any versions of ROS 2. Like you can run the basic version. So basically we are like optimizing the resources. So Linux is the primary operating system for ROS 1 and ROS 2, but if you have any application that need to be run in Windows and Mac OS, you can. Okay, that is again a big add-on. Okay, a big change in ROS 2. And another thing is like it's not, I mean, not much bothering us, but it's still I think a good addition. In ROS 1 we work with ROS CPP, ROS Pi and all, right? So these client libraries are independent libraries. Okay, they are not inheriting from some underlying library. Okay, the ROS CPP and ROS Pi are, I mean, they actually implemented ROS concept from the scratch. Okay, so if you want to create a topic, we have to use an API. Okay, so that API implemented in Python and C++. If you want to create a new client library in ROS 1, you have to create it from scratch. That was the situation of ROS 1. Okay, the problem is that you have to recreate every time for new language. Okay, but in case of ROS 2, there is an underlying C library called RCL. So the Python, C++ and everything can inherit or can use the underlying library somehow. Okay, and we are using the underlying C library, so the performance will not degrade that much. If you are working with Python or C++, it will not, I mean, that bad compared to the ROS 1. Okay, and there are other additions like if you are working with ROS 1, we can only work with single node per process. For example, you may be running the hello world talker and listener, right? So talker is a single node per process. Okay, so if you run like ROS run hello world talker, it is actually a process. Process means when you run a program, it will become a process. Running instance of a program is called process. So one process is only running one node. Okay, but in case of ROS 2, we can run multiple nodes, which is a good thing actually. So inside a process, multiple nodes can be run. For example, you can run talker and listener inside the same process. Okay, in some situation it will be useful. Okay, and next is the threading model. Like in ROS 1, callback queues and handlers. In rows 2, swappable executors. I will explain that later. Uh, if you remember, in rows 1, we have been using the callbacks and handlers, but there is a difference in rows 2. Okay, it's actually a better approach. And yeah, this is another interesting addition in rows 2. Very, very useful. I have also used this feature in multiple projects. So it will be useful for you, okay, for sure. I can explain it. What is this feature? So if you work with a rows 1 node before, like, is there any kind of control in that node? Like, we will be initializing the node, and then we will be doing some computation, and maybe you will be waiting for some topics, right? So it is basically like a publishing, subscribing, and there is no control in the node. Okay, but in rows 2 there is an approach called life cycle nodes. Okay, it's a kind of state machine kind of stuff. State machine means you can control the flow by giving the inputs. Okay, and based on the input the state will be changing. Okay, so in short, you can create nodes in rows 2, and you can control the flow of these nodes. For example, you can run the lifecycle node, and then you can, so you are running the node, and then if you activate it, if you just give a command to activate it, it will be starting. If you disable it, it will disable. Okay, if you run it, it will run, it executes something, and if you stop it, it will stop. So it's complete control of the node. Okay, so you can write regular nodes in rows 2 and also life cycle nodes. Life cycle nodes are very important. Like in big projects and all, no, if we are working with rows 1, we may be using some state machines like I forgot that we already discussed that in rows 1, right? There are multiple state machine available in rows 1, but we don't need to use any state machine for controlling the flow of a node. We can use the inbuilt features, which is life cycle nodes. Okay, I think you got an idea. Like, we can completely control a node by just giving the inputs. Okay, so here the lifecycle nodes are like can be triggered by calling some row service. Okay, row service and action. So this is very important feature, guys. Completely controlling the flow of the nodes. Okay, and again, this also we are familiar with. We work with row serial in rows 1, right? Row serial, what was row serial? It was like a protocol that the rows 1 guys written in order to communicate from a rows environment to an embedded board. Embedded board can be Arduino or like Tivasi Launchpad, any kind of board. Okay, so row serial is a kind of protocol that is created, and then what is the output of the row serial, or what is the main thing that we can achieve? So like an embedded device can able to publish, subscribe the topic or like parameters from a rows environment. For example, if your laptop is running on Linux and if it is having rows, you can publish some topics in from laptop, and that topic can be subscribed to an embedded board. Okay, using the serial cable. Okay, using the UART protocol. So I think you maybe heard about ROS serial Arduino. I think we already discussed that, but I can simply show you. This is how it is working. Like we have laptop with ROS, we have the embedded board, and connect the board to the USB, and then this Arduino board can be act as a ROS node. Okay, which is a very useful technology. I will say a lot of people switch to ROS serial because of the simplicity, and also it's very easy to manage. The code also very easy to manage. Otherwise, without ROS serial, we have to establish a custom protocol. Like, custom protocol means we have to send some raw values to Arduino, and raw values has to decode by Arduino, and also Arduino sends some values to computer, and computer has to decode. Okay, but using ROS serial and ROS serial server node, we can easily create an Arduino as a ROS node, which is a great thing. Okay, but again, that's a experimental thing. We can't use that for a product. It's not very reliable. But in ROS 2 we have micro ROS. I hope you heard about micro ROS. It's compatible with the products. You can use it for product, which is a great thing. Basically, we are running a it's not like ROS serial. We are running a very lightweight version of ROS 1, ROS 2 in a microcontroller. Okay, so that is the micro ROS. Okay, here you can see there is on the left side there is a ROS 2 agent, and the ROS 2 agent is connected through Ethernet, Bluetooth, or serial. And here on the embedded device we have an RTOS, okay, real-time OS. On the bottom we can see the microcontroller, right? Microcontroller, and on the top there is RTOS layer, okay, real-time OS layer, and on the top there is a very lightweight DDS client, micro XRC DDS client, and on the top there is a client library. So basically we are running a very lightweight footprint of ROS 2 on the microcontroller. Okay, this is far better than the ROS serial. Obviously ROS serial can able to publish and subscribe, but here in micro ROS we are running a instance of ROS 2, entire ROS 2 in a microcontroller, which is a great thing, right? But in ROS serial we are not running any ROS 1 or something in microcontroller. We are simply using some APIs which will be converting the publisher and subscriber, which will be doing the decoding and encoding. Okay, so this is a great project, micro ROS. So that is also a great add-on in ROS 2. And then there are changes in parameters access. ROS 1 was using a protocol called XML RPC. We were been using this technology to fetch the ROS parameter, but in ROS 2 it is using service calls. And then also parameter types, it is getting when we assigned, and in ROS 2 it is actually enforced. Okay, that you can ignore for now. Maybe when we discuss parameters you can discuss that. So these are the main differences they are putting in the paper, and also they are showing the block diagram of ROS 2, simple block diagram, how it is communicating. It's similar to rows 1, but there is no rows master. Okay, so here you can see node A is there, node B is there, node C is there. Okay, so there is no need of broker, that is master here. The peer-to-peer discovery is doing by the DDS. Okay, so we need to simply run the nodes and the nodes will be finding each other. Like if node A is if node C is publishing something, publishing some topic, node A and node B subscribing. Okay, so it will be automatically finding it. Okay, no need of any extra broker. DDS will handle everything. So that is this diagram, and this is the kind of architecture, or not architecture, but the title is client library stack. It's actually showing the client libraries in ROS 2. Okay, so you will get some idea of the architecture of ROS 2 here as well. Like on the bottom layer you can see the different DDS libraries like Cyclone DDS, Fast DDS, Connex DDS. Okay, and on the top you can see there is a interface library called RMW. Okay, so I mentioned that you can switch the DDS, right? Okay, you can switch the DDS. I forgot the 1 second. Yeah, so I forgot this full form of RMW. It's ROS middleware interface. Okay, yeah, ROS middleware interface, RMW. So what it does is that it is actually kind of abstract layer. Okay, so whatever the DDS that we are using, this is having some generic APIs. Okay, so it will be compatible with any DDS middlewares. Okay, so that is the interface. This stands for ROS middleware interface. Okay, and which is actually coded in C. Okay, and on the top of RMW we have RCL. This is what I mentioned, the C APIs. Okay, that is the core client library API, and on the top of this C API you can find RCL CPP, which is the client library in CPP. Client library of CPP for ROS 2, then RCL Py for Python, RCL Java, and you can create any client libraries with the help of the C APIs. So the main benefit is that the performance degradation will not be that much because the same APIs are exposing by different programming language. Okay, and using the client libraries you can able to create the applications. Okay, so I will say, like, just go through this. Okay, for today I'm just stopping the session. Like we are just discussing the architecture for today, and tomorrow if I get time I will be like going through maybe this graph. Let me see. It's showing some comparison of like the performance of ROS 2, which is very important. Like if you choose a framework, we should be impressed with this performance, right? Then only there is a need to switch from ROS 1 to ROS 2. So for today we can see the basic differences in the architecture level. Okay, and tomorrow let me see if there is anything missing, and then we will see that, and then we can start with the tutorial. Okay, tutorial series which is already there. You're simply following it, that's it. If you just check the tutorial list, we will be discussing these tutorials which is already there, so you can also practice it. You don't need to see the video, you can simply take this tutorial and then practice it. Okay, so tomorrow let me see, we can able to start that. So make sure you have installed the Rose to Humble in Ubuntu. Okay, if everyone is using the same setup, it will be easier for me. Okay, and after that we can start the hands-on sessions. Okay, so for today we are discussing up to this, and tomorrow we can start. I mean, if there is anything missing, I will be discussing that regarding the architecture, and in detail I'm not mentioning in I mean that very technical I'm not mentioning. As of now, you can simply understand these are the main stuff that is changed. Okay, and when I take the classes, I will be mentioning these changes in detail. Okay, okay, so just want to know, I mean, mention, you can just go through the paper which is the fundamental or like the base paper for Rose 2. You can just go through it, and tomorrow I will announce the time, class time, and then we can discuss. Okay, so let me know if you have any question in the basic I mean basic concept that we have discussed, and then if there is any question, we can yeah, we can conclude the session. Okay, so I think we can conclude today's session. Okay, so see you tomorrow, guys. I will announce the time and then we can discuss further. Okay, thanks for attending, guys. See you tomorrow. Bye. Good night.